So yesterday we saw that we can factor certain trinomials by using algebra tiles. Okay, Brock? Need to put your phone away. Not right now, you're not. You're paying attention to today's lesson. Pardon me? Thank you. So we saw yesterday that we can factor trinomials, certain trinomials, by using algebra tiles. Remember, when you factor, you're finding things that multiply together to get what you start with. And I've said this more than once, that you're going to use factoring all through high school mathematics. Sometimes we use factoring for solving certain equations. Sometimes we use factoring so that we can simplify rational expressions. A rational expression is like a fraction that involves polynomials. Okay? So factoring is a big part of math in high school. You need to know how to do this. So we saw yesterday that we could factor this polynomial by building it inside the diagram. We've got a positive 1x squared, and we said that the x squared tile always goes in the top left-hand corner. And then the last term is a positive 4. So we're going to have 4 positive 1 tiles, and they always go in the bottom right-hand part. And however you arrange them, they must form a triangular shape. So you would have two options here. You can go 4 wide and 1 high like I've done. And if that doesn't work, maybe you go 1 wide and 4 high, or maybe 2 and 2. 2 wide and 2 high. Okay? Sometimes all of them will work. Sometimes only one of them will work. And then we're also going to see that in some cases, nothing will work. But we're going to get to that. So how many spaces do we have to fill in here, Keen? 5. Right, and we need 5 x's, right? The middle term is positive 5x. We have 4 spaces above the 4 1 tiles and 1 space to the left of them. So we've got 5 spaces to fill in with positive x tiles, which are those skinny rectangular ones. So there's our 4 x's, and there's our last x. There's our 5 x's. So we've made a rectangular shape here, right? So, Jan, what's the factor on the top? Yes, because you have 4 tiles here that are 1 wide. 1 times 4 is 4. They're 1 wide and there's 4 of them. What's the factor on the side, Brooklyn? That's right, x plus 1. Again, this big square tile is x by x. That's how wide and high it is. That's where the x comes from. So we're saying that the factors are x plus 4 and x plus 1. And it doesn't matter what order you write them in. You can do the x plus 1 first, the x plus 4 second. It doesn't matter. Sal, do you remember what we can do to check to make sure that they are correct? You're going to multiply them out using distributive property. That's right. Remember, factors are things that multiply together to get what you start with. So if you multiply these out, you should get what you start with. So x times x is x squared. X times 1 is 1x. 4 times x is 4x. 4 times 1 is plus 4. And again, the 1x plus the 4x gives us 5x's. So that matches the trinomial that we started with. That confirms that those are the correct factors. Remember, factors are things that multiply together to get what you start with. On the next page, let's see if we can do this one. Again, you're going to have a positive x squared in the top left corner and a plus 6 in the bottom right. So we need 6 positive 1 tiles. And so let's try to do 3 wide and 2 high. There's our positive 6's in the bottom right-hand corner. How many spaces do we have to fill up here? Emery? Princess, put your phone away. That's right, we got 3 here and 2 there. But we have to make 4 x's out of this. And remember, all the positive tiles have to kind of go together. All the negative tiles kind of have to go together. So this won't work the way we have it right now. If you put 3 positive here and 2 positive down there, you'd have positive 6 x's. That's not right. If you put 3 positives here and let's say 2 negatives, that's only going to give you positive 1x. Won't work. If you put 3 negatives up here and 2 positives down there, that's going to give you negative 1x. Won't work. Right? So sometimes it does matter how you set up your 1 tiles. So let's try and change it so it's 2 wide and 3 high. We already know that 5 tiles won't work. And again, we have 5 spaces to fill in here as well. So that won't work. Okay? Well, what if we make 1 wide and 6 high? Now we have 7 tiles to fill in, but it still won't work. If we make all these positive down below, that gives us 7 tiles, positive 7x's. If we make the one at the top negative, 7x minus 1x gives us 6x, not 4x. This one cannot be factored. Not all of these trinomials can be factored. Sometimes there are no factors. Sometimes. On a quiz or a test, if you're asked to factor a polynomial, though, they can all be factored. But as we go through examples and some of the questions maybe in the homework, once in a while you're going to see ones that cannot be factored, right? So you need to be prepared for that. All right, so we've seen how we can use algebra tiles to factor these special trinomials. And again, these trinomials have a definite pattern to them where the first term is an x squared, the second term is just an x term, and the last term has no x. It's a constant. So these are called quadratics. Whenever you have a polynomial with a degree of 2, that's a quadratic. And in 20-1, you'll spend 2 chapters just studying quadratic functions, these types of polynomials, right? But here, we're just factoring them. So we've seen how we can use algebra tiles to factor them and then find out that some can be factored, or can't be. But it'd be nice if we had an algebraic way of doing this, so we don't have to use these algebra tiles anymore. And so that's what we're going to look at now. How can we factor these without doing that? Here's how this works, all right? We know that if factors exist for these trinomials, the factors will both be binomial factors, right? All of these trinomials follow that same pattern that we've been doing. Not all the variables are x, and that doesn't matter. But the first term, whatever the variable is, that variable is squared. The second term has that same variable to the power 1. And the last term doesn't have any variable, which means it's a constant. So all of these follow that same pattern, where you've got a squared term, a term with no power, which means it's positive 1 on the variable, and then a constant with no letter at all. If factors exist, and all the ones that we factored yesterday and the one that we factored today, if they exist, you're always going to get 2 binomial factors. All the ones we did yesterday, that's what we got, 2 binomial factors. The first one we did today, 2 binomial factors. So if the factors exist, they'll be binomial factors. Now, we've seen that we can always check by multiplying them out. These 2 front terms, the 2 front terms of each binomial will be the terms that multiply together to give you the x squared. So because of that, they both have to be x's. The x times the x will give you the x squared. Now, the last term of the trinomial is positive 16. These last 2 numbers must multiply to get positive 16. That's where this last number of the trinomial will come from. It'll come from multiplying the 2 last numbers in each binomial together. So you have to ask yourself and think about what 2 numbers multiply together to get 16. Now, there are different numbers that will. 1 times 16, 2 times 8, or 4 times 4, right? So here's what you do. Not only do these two numbers have to multiply together to get 16, they also actually have to add together to get that number in front of the x, the coefficient of the middle term, which is plus 10. So the two numbers that we're looking for will multiply together to get 16 and add together to get 10. So they must be 2 and 8, or 8 and 2. They multiply to get 16, they add to get 10. And it doesn't matter whether you put the 2 first or second. But we also have to have a sign in between the x and the 2 and a sign in between the x and the 8, and they will both be positive because our two numbers have to multiply to get positive 16, which means they have to have the same sign, and they add to get positive 10, which means they both have to be positive. So we are saying that these are the factors, and we can check them by multiplying them out using the distributive property. So x times x will give us our x squared. X times 8 is positive 8x. Positive 2 times x is positive 2x. Positive 2 times 8 is positive 16. So what does this tell us, Brock? What's 8x plus 2x equal? If you add those two together, what do you get? Yes, this tells us that our factors are correct because the answer we got when we simplify it matches what we started with. We've got our x squared here, we've got our positive 16 there, and if you add the 8x and the 2x together, you'll get the plus 10x that's at the top. Our factors are correct. We just showed that they work. Factors are things that multiply together to get what you start with. And we've just shown that those two do multiply together to get what you start with. So they are the correct factors. So this is how you do these without having to use algebra tiles. This next one, u squared, take away 4u, take away 21. Again, this is one of those trinomials that follow that same pattern. You've got the u squared as your first term, the second term is a u term, and the last term is a constant. If factors exist, they will both be binomial factors, and the front terms have to multiply together to get u squared. So because of that, you need u's in the first position of each binomial. So to figure out what these two last numbers need to be, you need to ask yourself, what two numbers multiply to get negative 21, add to get negative 4? The factors of 21 are only 1 and 21 or 3 and 7. And 3 and 7 differ by 4. So those are the two numbers that we will use. They multiply to get negative 21, which means the signs have to be different, one positive, one negative. Because they must add to get a negative 4u, because of that, the bigger number, the 7, must be the negative one. The 3 must be the positive one. When you multiply 3 and negative 7 together, you get negative 21. And when you add 3 and negative 7 together, you do get negative 4. So those should be the factors. And we will check by actually multiplying. Use a distributive property. So u times u is u squared. U times negative 7 is negative 7u. 3 times positive u is positive 3u. And 3 times negative 7 is negative 21. We've got the u squared that we needed. We've got the negative 21 at the end that we needed. And if you simplify the inner terms, negative 7u plus 3u does give you the negative 4u. We have just shown that our factors are correct. They do multiply together to get what you started with. So we can do this algebraically. We don't need to draw those algebra tiles anymore. Right? Question, or the next one. And when you're asked to factor a polynomial, the very first thing you always look for is a common factor. And so far for any of these, there has not been a common factor. Okay. When we get to the ones at the bottom, there are common factors. So we'll address those when we get there. But for these first ones, there haven't been. So if factors exist, the factors will be binomial factors. And the front terms multiply together to get n squared. So Cheney, what would we have to put in the first position of each binomial? Because why? N plus n? Is that what you said? N times n. Yes. Those front terms must multiply together to get n squared. So that's why they both have to be n's. Now what are we looking for, Brooklyn? Brooklyn Dreyer. The number after what? Okay. And how do we figure out what those numbers need to be? Nope. There's no common factor here. You're looking for two numbers that multiply together to get that last number. Multiply together to get negative 10 and add to get the middle number, coefficient, negative 3. Yes, Riley, you got something to say? Spit it out. Okay, 2 times 5 is 10, and 2 and 5 do differ by 3. So we can put the 2 here and the 5 there, but we also need the sign in between them. You agree with that, Jan? Why not? Don't tell me to wait. I'm in charge here. I'll tell you to wait. Oh. Ooh. Well, there's only one that's right. There's only one way that's right. Why does the 5 need to be negative? Because they add to get negative 3. If you add these two numbers together, you're going to get positive 3. Yes. There's only one correct answer. Because they have to add to get negative 3, the bigger number must be the negative 1. Make sense? Okay. Are we done, Brooklyn? What should we do? We should check it by yes multiplying. See what n times n minus 5 plus 2 times n minus 5 gives us. If it doesn't give us what we started with, then our factors are not correct. So what does the next line look like, Kenzie? Put that away. What does the next line look like? I'm sorry? N times n is n squared. N times negative 5 is negative 5n. 2 times n is positive 2n. And 2 times negative 5 is our negative 10. So we've got the n squared. We've got the negative 10. If you combine the negative 5n plus 2n, you do get negative 3n. You do. So we have just shown that our factors are correct. We've just shown that. Our factors are correct. All right, next one. There is no common factor there. So if factors exist, they will be binomial factors. The front terms have to multiply together to get t squared, so they both have to be t's. You cannot put a t squared in the first bracket and a positive 1 in the second. It won't work. Right? You won't get the factors. Remember, you're looking for what multiplies together to get what you start with. That's why we're always checking by multiplying. What now, Brock? What are we looking for now? And that's it? Because 1 times 10 is 10. Will that work? That's right. Yep, absolutely. Multiply to get positive 10, add to get positive 7. What numbers work there, Keen? What about their signs? Because they multiply to get positive 10, which tells us the signs have to be the same, and they add to get positive 7, so they both need to be positive. And again, we can check by multiplying. make sure that they multiply out to get what we started with. So t times t is t squared. T times 2 is positive 2t. 5 times t is positive 5t. And 5 times 2 is positive 10. If you add the 2t and the 5t together, you'll get 7t, which is the middle term. We've got the right t squared. We've got the 10. We've just shown that our factors are correct. There is only one set of factors that'll work for these. And you can always check by multiplying. So the next one also involves the variable t. There is no common factor. So if factors exist, they'll be binomial factors. And because those front terms multiply to get t squared, they both have to be the letter t's. Now what, Jensen? One and 12? We're looking for two numbers that multiply together to get negative 12, add to get positive 1. 1 and 12 do not differ by 1, they differ by 11. What else multiplies to get 12 besides 1 and 12? Yes, Kai? 2 and 6, but they differ by 4. They don't differ by 1. Yep. 4 and 3. Or if you're really smart, you'd say 3 and 4. Okay? It doesn't matter, obviously. But we need to figure out what the signs are. They multiply to get negative 12, which means the signs have to be different. One positive, one negative. They add to get a positive 1. So the bigger number must be the positive 1. The 4 has to be positive. So that when you add them together, you get positive 1, not negative 1. So we'll check. We'll multiply them out to make sure that we do get the correct trinomial. T times t is t squared. T times negative 3. 4 times t. And 4 times negative 3 is negative 12. Is it right, Brooklyn D? How do you know? Can't hear you. Pardon? Did I? I've got the right first term, t squared. Do I have the right last term? What should the last term be? Yeah, last term up here is negative 12, and we got that. When you combine negative 3t and positive 4t together, Brooklyn, what do you get? Positive 1t, which is right. That's how we know that our factors are correct. Again, there's only one set of factors that will work. Next one, no common factor there. So if factors exist, they will be binomial factors. So we start by putting down the double set of brackets. Cherry, what goes in the first space in each bracket? 1v for each, because they need to multiply together to get v squared. Now what are we looking for, Chloe? Say again. Multiplies together to get what? And what do they add together to get? The 5. So the signs are important. You said multiply together to get 50. It's actually negative 50, and that makes a huge difference. But yes, they multiply together to get negative 50. They add to get positive 5. So you think of what multiplies together to get 50, probably the first one that comes to mind maybe is 2 times 25. But you cannot add or subtract them together to get 5, the middle term. So you need to think of two other numbers, and 5 and 10 multiply together to get 50, and they do differ by 5. Now up here I wrote plus, and I talk about them differing. You see if the signs are different, sometimes you're taking one from the other, right? When you have a positive integer and you add a negative integer, we've also done that by subtracting a positive integer, right? So that's why I say sometimes we're looking for numbers that either add together to get the middle term, but also sometimes differ. But we need to figure out what the signs are. They multiply to get negative 50, which means they have to have different signs. One positive, one negative. Because they add to get a positive value, positive 5, the bigger number must be positive. The smaller number must be negative. So those should work. We will check by multiplying using the distributive property, right? And this multiplying distributive property, it's going to be on the quiz you guys are writing after the notes today. So this is practice for the quiz as well, this part. There won't be this type of factoring on the quiz. I told you that. So v times v is v squared plus v times 10 is 10v. Negative 5 times v is minus 5v. And negative 5 times 10 is negative 50. Are the factors correct, Declan? How do we know? Right, and that is the middle term of the trinomial. Also, we've got our v squared and our negative 50. So we have just shown that our factors are correct. You should never get these wrong because you can always check by multiplying them out. Next one, no common factor there. So if there are factors, they'll be binomial factors, so that's where we'll start. We'll put down a double set of brackets. Ava, what goes in the first position of each binomial? Right, because they need to multiply together to get m squared. What else are we looking for, Peyton? Times to get negative 8 and? Right. Do you know what those numbers are, Peyton? Will those work, Sophia? Sure. They multiply to get negative 8. They add to get positive 2. So they should work. And we can figure out or check that they do work by multiplying them out. M times m is m squared. M times negative 2. Positive 4 times m. 4 times negative 2. So Cherry, do our factors work? Because I've got the m squared here that I need. I've got the negative 8 at the end that I need. And negative 2m plus 4m does give you plus 2m, which is that middle term. So our factors are correct. We just checked them. Try the next one on your own. Yes, ma'am. Doesn't matter if the m minus 2 is first and the m plus 4 is second. But you must have a plus 4 and you must have a negative 2. Yes, ma'am. We're almost done. When we're done, you can go. If you can wait. You working on this, Kenzie? Sorry? You did it already? Did you check it? Okay, then you can go to the next one. Did that one too already? Or maybe you can start teaching my class for me. You seem to be on top of this. So you're ready for that tomorrow, teach the class? No, I didn't think so. You got these done, Jan? Yeah? How confident are you, Jan? Really? Lots of confidence? Brody, when we're done, if you can wait. All right, Kenzie, what did you get for the factors for this one? N plus 5, n minus 4? Is that what you said? You agree with that, Keen? Yeah. You want to bet a pop on that, Keen? You owe me a pop, Keen. Well, they have to add to get -1, not +1. You're looking for two numbers that multiply to get -20. They add to get -1. So the 5 has to be negative and the 4 has to be positive. I love it when Keen owes me pops. Is that right? He owes me 3 now?
3.
Or is it 4? Maybe it's 4. 5? You might be right. So again, to make sure, check. Check by multiplying them out. Using the distributive property. So you've got the right first term, the n squared. You got the right last term, the -20. 4n take away 5n does give you -1n. We've just shown that those are the correct factors. Who did the next one already? Okay, Princess. What'd you get for the factors? So you're saying the two numbers that multiply together to get +12 and add together to get -8 are -6 and -2. That's what you're telling us. You expect us all to buy that. It's not, it's right. They do multiply to get +12. They do add to get -8. However, we will check just to make 100% sure. We will actually multiply them out to check. B times B is B squared. B times -2 is -2B. -6 times B. Then -6 times -2 is +12. You've got the B squared that you needed. You got the +12 that you needed. And when you put -2B and -6B together, you do get -8B. So we have just shown that our factors are correct. Okay? So these last three, before you guys get your quiz to do. Yes, ma'am. I'm sorry? And what is the other factor? You need two factors, right? Okay. Yep. And if you would have checked it, it wouldn't have worked, right? If you look back at what you started with. Okay. Always look for a common factor first. And for this next one, there is a common factor of 2 that you would start by taking out. Remember, that's your first factor. Your second factor is what you get when you divide all the terms by that common factor. Divide each term by the common factor to get what's inside the brackets. And now you're going to see if you can factor that trinomial. But you can't forget about the 2. It's one of your factors. Remember, you got to multiply out your factors to get what you start with. So that common factor of 2 must be carried down. It's one of the factors. It has to be part of the final answer. So the front terms of these binomials will multiply to get p squared, so they both have to be p's. Now what are we looking for, Allie? And how do we know what those numbers need to be? They multiply to get -12. They add to get -4. So think of the things that multiply to get 12. 1 times 12. They can't add and subtract to get 4. 3 times 4 multiplies to get 12. They don't add or subtract to get 4 either. Jan? They multiply to get -12, and they also add to get -4. So those should be the correct factors. But we will check by actually multiplying. Now, in this case, we've got 3 things to multiply together. You just go left to right, which means you're first going to multiply the 2 by the p minus 6. That'll give you 2p minus 12, which then has to be multiplied by the p plus 2. You only multiply the 2 by the next factor. Now, to multiply these two binomials together, we must use distributive property. Again, you might see a question like this on your quiz today. So this is more review for your quiz, where you're multiplying three things together. So when you multiply all these out, you've got the 2p squared at the start that you needed. You've got the negative 24 at the end that you needed. And when you go 4p, take away 8p, you do get negative 8p. So we have just shown that these factors are correct. We've just shown that. All right, the next one, I would take out a common factor of negative 2. It is really a lot easier to factor the trinomial if the first term, the squared term, is positive. So by taking out a negative 2, you're going to get a positive g squared, a minus 11g, and a positive 24. But the key is you want the squared term to be positive. It makes that next step a lot easier. So we're going to see, can we factor that trinomial? The front two terms must multiply together to get g squared. So that's why they both have to be g's. And we're looking for two numbers that multiply to get positive 24, add to get negative 11. Because they multiply to get a positive value, they both have to have the same sign. They're going to add to get a negative, which means they both must be negative. It'll be negative 3 and negative 8. They multiply to get positive 24. They add to get negative 11. You could put the negative 8 in the first bracket, the negative 3 in the second. That doesn't matter. They just both have to be negative. So to check this, we'll multiply. First, the negative 2 times the g, take away 3. Will give you negative 2g plus 6. And then that's multiplied by g minus 8, which we use a distributive property for. So we'll get negative 2g squared. Negative 2g times negative 8 is positive 16g. 6 times g is positive 6g, and 6 times negative 8 is negative 48. We've got the negative 2g squared that we needed. We've got the negative 48 that we needed. 16g plus 6g gives you your 22g in the middle. We have just shown that these are the correct factors. And the last one. There is a common factor there of 3z that you would take out first. All these trinomials that we're factoring, they have the variable squared as the first term. So to get all these terms inside the bracket, the other factor will divide each term by 3z, and you'll get z squared. Negative 24 divided by 3 is negative 8z, and negative 99z divided by 3z is negative 33. So if that trinomial can be factored further, they will be both binomial factors. The front terms have to multiply to get z squared, so they both have to be z's. And now we're looking for two numbers that multiply to get negative 33, add to get negative 8. They will be negative 11 and positive 3. They multiply to get negative 33. They add to get negative 8. To make sure, we'll multiply these out to check. First, we'll multiply the 3z by the z, take away 11. That'll give us 3z squared, take away 33z. That's now multiplied by z plus 3 by, again, using distributive property. So that'll give us our 3z cubed. 3z squared times 3 is positive 9z squared. Negative 33z times z is negative 33z squared. And negative 33z times 3 is negative 99z. I've got the 3z cubed that I needed. I've got the negative 99z at the end I needed. And or 9z squared take away 33z squared is 24z squared, which is the correct middle term. So we've just shown that our factors are correct. Okay? So your homework that you're going to hand in for marks is the next page. Only one side. So there's only 8 that you have to do there. Look for a common factor first. If there's no common factor, then you'll factor the trinomials like we did. If there is a common factor, like there will be for question, no, maybe for this one's there are none. Yeah, there is for question 6. Take out the common factor first. Don't forget that that's part of your answer, that common factor. So again, this one will be due for marks. But first, you're going to do the quiz, so you need to clear off